In this video, I'll be walking through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 1-3. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video as you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around my channel. Okay, let's get into the maths. In question 3, we're given this integral here. We're told it equals 12. This is an equation with only one unknown in it. This a here is missing. So we can solve this. We do out the integral. Whatever the answer we get, we put it equal to 12 and hopefully we can rearrange it and find out what a is equal. Now, integration works quite nicely on things added. This is actually two different integrals. It's the integral of this mess, which we'll spend most of the video doing, and the integral of 2. We'll ignore, actually, let's get that out of the way now. The integral of 2 with respect to x between 1 and 3 is simply 2x evaluated between 1 and 3. Put 3 in, we get 2 3s are 6. Take away, put 1 in, 2 1s are 2. That is equal to 4. The integral of 2 is 4. We'll ignore that and come back to it later in the video. For now, all we're going to concentrate on is the integral of a. My a's and 9's look very similar, so I apologize for that already because there are a few 9's in this question. A divided by 4 over x minus 3 to the power of 2 with respect to dx. This is what we're going to concentrate on for most of the video. Okay, lots of students are able to do this in their head. If you are able to do this in your head, you're probably not watching this video. So let me spend a bit of time doing it a little more slowly. We're going to use substitution. When you have an integral that's too hard for you to do, you tend to just substitute something. The most obvious thing to substitute here is what's in this bracket. So let's do that. Instead of this bracket, we're going to write a u, and that u will be equal to 4x minus 3. This is what we're going to substitute out. And we don't know if it'll work yet. I do because one, I've done it and I have lots of experience. But don't worry, you might just have to substitute a couple of times and see if it works for you. You should have plenty of time in an exam. I know it doesn't feel that way, but if you get a few questions right, they should go quickly and you'll have time to experiment on a few others. And 1 or 2 questions you just can't do and you have to throw away entirely. Okay, u is equal to 4x minus 3. When we're substituting, we also want to differentiate. That's because we want to replace this dx. So if we differentiate this u, we get du dx is equal to 4. And the fact that this is so simple, 4, is why a lot of students can do this in their head. I'll show that in a few moments, I think. If I rearrange this so dx is on its own, like multiply both sides by dx, divide by 4, we get dx is 1 over 4 du. Now I can replace it. So let me write all of this again. Instead, a will stay the same. Instead of the bottom row, we'll get u squared. Instead of dx, I'll get 1 over 4 du. I've left off units here. You can leave these off till the very end and change it all back into x's. That's fine. What I will do though is when x equals 1, what does u equal? 4 1s is 4, take away 3. U is also equal to 1. When x is equal to 3, up here, put a 3 in here, we get 4 3s are 12. 12 minus 3 is 9. U is equal to 9. So instead of doing this question, it is perfectly okay to do between 1 and 9 for u. So this is a much easier integral to do. Let's clean it up a bit more. This a, which I know looks like a 9, this a can come outside. It's just a constant, it can come outside. This 4 can come outside. So we'd have a divided by 4 and the integral between 1 and 9 of, and instead of u squared, I'm going to write u to the power of minus 2 du. This is very easy to do. We can do this quite simply. I'll continue it on down here. A divided by 4, and integrate this. We add a number onto minus 2. That gets to minus 1. Use minus 1. then we divide this by -1. Dividing by 1 doesn't do anything. Dividing by a minus is the same as multiplying by a minus. We just get a minus out there. And this is evaluated between 9 and 1. Let me just rewrite this one more time. Minus a divided by 4 u, because this u is on the bottom row. Evaluated between 9 and 1. God, my a's and 9's look too much alike. I'll have to work on that. Okay, let's put them in. Let's put 9 in here. We get minus a over 4 9's. That's 36. Take away minus a over 4 1's. That's 4. We just need to clean this up. These two minuses turn into a plus. Let me just rub one of them out. We need the bottom rows to be the same, so let's multiply them both by 9. Multiply the top by 9. See, there's a slight difference. So we have 9a take away 1a. That's equal to 8a over 36. That's the integral of this term. I think, you know what, I think I can even squeeze the answer up in this little corner, because the integral of this was 8a over 36. The integral of 2, which I'm not sure if I rubbed it out, here it is, here is 4, so that's plus 4, is equal to 12. Rearrange this, take 4 from both sides, we get 8a over 36 is equal to 8. Divide both sides by 8, that leaves a 1 there. Multiply both sides by 36, we get u is equal 36. Sorry, u, that should be an a, shouldn't it? That was an A all along. That was an A. Oh my God, my A's look like U's as well. I have to go to calligraphy classes, I think, if I want to stay teaching. Right, that's it for question 3. The constant A is equal to 36. Final answer. If you have any follow-up questions, probably about my handwriting, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.